Hello everyone. So let's see the solution of assignment 3. So I hope you have already attempted it on your own. So now we will see the solution. So in this question you need to find the value of Vx and I naught. They had written Ix, but they are asking the value of I naught. Okay. So finding the value of Vx, I guess it will be easy for you. Tell me the value of current in this branch. That will be 0.25 Vx plus 3, right? So you can write 0.25 Vx plus 3 into 2 is equals to minus Vx. Current into resistance, but the direction of current is this, so it has to give the voltage drop like this. So we have to write minus Vx. So from here your value of Vx would be coming out to be 0.5, 1.5, 0.5, 6 upon 1.5 minus 4 volts, right? So the value of Vx is coming out to be that is coming out to be minus 4 volts. Okay, now you need to find the value of I naught. So tell me one thing, do you know the potential of this point? Do you know the numerical value of V? You know the value of Vx, but you don't know the potential drop across these current sources, right? So you don't really know the value of V. If you had known the value of V, you could have simply written V by 10 minus 5 is equals to minus I naught. Sorry, V by 10 plus I naught equals to 5. So from there you could get the value of I naught, but you don't know the value of V. So you have to apply equations now. So one equation I can see here is that, what is that equation? That is V by 10 minus 5 plus I naught is equals to 0. Here I am applying. If the potential of this node is V, this node will also be V, this node will also be V, and this node will also be V, this node will also be V. So here I am applying, okay, V naught by 10 incoming current minus 5 plus I naught equals to 0. So basically 0.1 V naught plus I naught is equals to 5. So this is equation 1 we can write. One more equation we can write, that is V by 5 plus V by 5, it will be minus 0.8 I naught. What is the current here? The current in this branch. Vx value is minus 4 and 2. So minus 4 by 2. That means minus 2 ampere. So minus 2 ampere current is going outward. So 2 ampere current will be coming inward. So I will write minus 2. What is the current downward? That is minus 5 plus V by 10 equals to 0. I just wrote the current in all the branches. V by 5 minus 0.8 I naught. In this branch minus 2 ampere minus 5 ampere plus V by 10 equals to 0. So from here, from using equation 1 and 2, you will get the value of V. So the value of V would be equals to 2.1 ampere. Sorry, 2.1 volts. Okay. Sorry, not value of V. Value of Vx is already you know. And don't care about the value of V. We just need to find the value of I naught. So value of I naught you will get is 2.1 ampere. Okay. So by solving the equation, we get the value of I naught equals to 2.1 ampere. Let's move on to the next question. In this question, you need to find the value of I1, I2 and I3. Okay. So 3 loops, 3 equations, you will get the value of I1, I2 and I3. Very easy question. So let me call this one as loop 1, this one as loop 2, this one as loop 3. This question is just for practice so that you understand how to write the equations quickly. If you solve these kind of question, you will be able to write down the equations quickly. So how will you write? For L1 I am writing, for loop 1 I am writing. So 120 volts is equals to, for I1 I will write, for this loop I am writing, right? So in case only considering in this loop, how many currents are there? I1 current and I3 current. Sorry, I1 current and I2 current. Let's just call this loop as L2 and this loop as L3. Okay. So in this loop, we have only two currents, that is I1 and I2. In this loop, we have I1 current here and I1 minus I2 current here. So we have only two currents, I1 and I2. So we would expect the current to flow like this from 120 volt battery. So I1 is flowing in the opposite direction. So 120 volt will be equals to minus 40 I1, and I2 is flowing like this. So in the same direction we would expect plus 10 I2. If you don't understand this, no problem. Just write down the way that you used to write. Just write down the value of current, mark the sign, then see the potential. Or what I am saying is that from 120 volt battery, from this battery, what you would expect? You would expect the current to flow like this. But this I1 is flowing like this in the opposite direction. So I1 is flowing from 10 and 30 ohm. So minus 40 I1 plus I2 is flowing like this. I2 is flowing like this. So you would expect in this direction only. So I2 is flowing in the same direction. So plus 10 I2. Got it? Now you will apply the KVL in loop 2. So in loop 2, how many currents are there? I2 current is there. This I2 current is there. I1 current is also there. I3 current is also there. Okay. So in loop 2, so let's just talk about, like, there is no voltage source. So I have to walk. Let's just assume I am walking like this. I am walking in the direction of I2 only. So basically 50 30 plus 10 plus 10, 50 I2 will be equals to, I1 is flowing in the opposite direction and I3 is flowing in the opposite direction as well. Like I1 is flowing like this and you are walking like this. You are walking like this and I3 is flowing like this. So both of them are in opposite direction. So 50 I2 will be equals to 10 I1 plus 10 I3. Now in loop 3, simple KCL KVL we are writing, nothing else. In loop 3, you would expect the current to flow like this. I3 is flowing in the same direction. So 120 volt will be equals to 40 I3. One more component is there. What is that? That component is of I2, but that's in the opposite direction. So minus 10 I2. So that's it. These are the three equations. So did you understand how did I write it? First, write it down in the same way that you used to write. Then try thinking about this manner. You will slowly understand. 50 I2 plus opposite direction 10 I1, 10 I3. So 50 I2 equals to 10 I1 plus 10 I3. In loop 3, 120 volt, I3 will be in same direction. So 40 I3, I2 is in the opposite direction. So minus 10 I2. So by this you write down the equation. You will get the value of I1, I2 and I3. So value of I1 is minus 3 ampere, I2 is 0 ampere and I3 is 3 ampere. Okay, let me recheck it once again. If we write down the value here, so yeah, that's fine. Okay, so that's the final answer. Now you need to find the value of current again. So you just need to find the ratio of I0 by Is. Okay, you need to find the ratio. Very easy question. If this node is 0, this node will be V node. You can apply the nodal here. Okay, so V node by 75 plus, if this is V node, this is minus 9 V node. So V node by 75 plus tan V node by 50 is equals to Is. So this is equation 1. One more equation you can see is that 9 minus 9 V node by 150 ohm is equals to I node. Did you get this equation? Minus 9 V node by 150 ohm is equals to I node. The current in this branch. Minus 9 V node by 150 ohm is equals to I node. Okay. Now you need to find the value of I node by Is. So you need to replace V node with minus 150 by 9. What is the value of 150 by 9? Minus 150 by 9. I will just solve it. 16.66 minus 16.66 I naught. I will better call this equation as equation 2. So just replace V naught with this value and you will get the value of I naught by Is. Right? So that value is minus 0.281. Okay. There can be some error in the calculation. I hope there is no error in all the questions, but if there is any, just mark it out. Okay. Yeah, so that's the final answer we are getting. Let's move on to this question. You need to calculate the value of V naught and I naught. Tell me, what is V naught? V naught is 20k into 50 I naught. That means it is 10 to the power 6 I naught. So this is V naught. 20k into 50 I naught. So 100 आया. So 20 into 5, that is 100 into 1 more 0. Yeah. So 10 to the power 6 I naught. This is equation 1. There is one more equation. V naught by 100 minus 15 millivolt by 4k is equals to I naught. Right? V naught by 100 minus 15 millivolt 0.05 by 4k is equals to I naught. So 0.01 V naught minus 0.15 is equals to 4 into 10 to the power 3 I naught. From here you can put the value of V naught, that is 10 to the power 4. Value of V naught is 10 to the power 6 into I naught. So this is equation 2. So by equation 1 and 2, by solving equation 1 and 2, 1 and 2, 10 to the power 4, so it will be 6 into 10 power 3 I naught, yeah, equals to 0.015. So I naught value you will be getting is, just solve it by equation 1 and 2, you can solve it, you will get 2.5 microampere. Or I think I should solve it here because you guys haven't solved these equations. So 0.01 into what is the value of V naught, that is 10 to the power 6 I naught, minus 0.015 is equals to 4 into 10 to the power 3 I naught. This will be 10 into 10 to the power 3 I naught, right? Because that will be 10 to the power 4. So 10 into 10 to the power 3 I naught will be equals to 6 into 10 to the power 3 I naught is equals to 0.015, right? So do I have the next page? Let me add a page. So from here we will be coming, I naught will be equals to 15 into 10 to the power minus 3 upon 6 into 10 to the power 3. That will be equals to 2.5 microampere. This is I naught. Okay, so I naught value is 2.5 microampere. Now what will be the value of V naught? V naught will be equals to 2.5 volt, because V naught is equals to 10 to the power 6 I naught. That means it will be equals to 2.5 volt, right? Okay, let's move on to the next question. You have to find the value of V naught in this question. Okay, so tell me what is the value of V naught? V naught is minus of 5 kilo ohm into 400 I naught. Are you agreeing to this point? Or I can write minus 2 into 10 to the power 6 I naught. This is your V naught value. Why so? The current 400 ampere is 400 I is flowing like this. 400, not I naught. This is just I. Okay, this is just I. 400 I is flowing like this. So 400 I into 5k. So it is minus 2 into 10 to the power 6 I. So V naught value is this. Okay. Now tell me one thing. If this current is I and this current is 400, so what is the value of this current? That is 401 I. So now I can just apply KVL in this loop, right? I can apply KVL in this loop. So what I will do? This is equation 1. So 47 millivolt, that means 0.047 is equals to I into 1 kilo ohm, that means 10 to the power 3, plus 401 I into 2 kilo ohm, right? That means 803 I into 10 to the power 3 is equals to 47 milli. 47 milli. Okay, so I will be equals to 47 by 803 by 803. That will be 0.0585 microampere, or you can write 58.5 nanoampere. This is the value of I. This is the value of I we get. Now what will be the value of V naught? That will be minus 2 into 10 to the power 6 into 0.0585 into 10 to the power minus 6 because micro. So what you will get into 2. So 0.117 volt. This is the value of V naught that you get. Well and good. Easy question, nothing is there. As I is coming, 400 I is coming. So 401 I is going that way. So 0.047 millivolt is equals to 1 into 10 to the power 3 into I plus 401 into I into 2 into 10 to the power 3, right? 2 kilo. So from here you get the value of I, and if you know the value of I, you can write down the value of V naught as well. That's it. Well and good. Let's move on to the next question. You have to find the current gain, V naught by Vs. This is one different circuit. This is one different circuit. You can apply the voltage division here, right? Because 3.5 kilo ohm and 500 ohm, both of them will be having the same current, right? So you can apply the voltage division. Applying voltage division. Applying voltage division, your V1 would be equals to 500 by 4000, because 3.5k is 3500, 4000 into Vs. It will be equals to Vs by 8. V1 is equals to Vs by 8. This is equation 1. What is the value of V naught? V naught is equals to minus 80 V1 by 2. So that will be equals to minus 40 V1. V1 is Vs by 8. By equation 1 I will write here. We are doing nothing. V naught is equals to minus 80 V naught by 2, because 500 ohm and 500 ohm, it will be equally divided. So by 2, so that is minus 40 into V1. V1 is Vs by 8. So simply we get V naught by Vs is equals to minus 5. That's it. Okay, let's move on to the next question. So I guess like these kind of questions you haven't seen in network analysis. So we will understand it deeply in analog electronics actually. Okay, we will understand it deeply in analog electronics, but let's just see it. So what is base potential? What is emitter potential? If you don't know, you can simply skip this question. So this is what we call base, this is what we call emitter, and this is what we call collector. Okay, we will understand this question in analog electronics as well. We will study deeply in analog electronics. Okay, no need to worry. So this is base, this is emitter. So the potential VB is 0.7 volt. They are saying the potential VB is 0.7 volt. Now this current is known as IB current. Okay, and this current is known as collector current, IC current. Okay, so if you don't know all these things, there is no need to worry. We will understand in analog electronics. Okay, so I can apply the KVL in this loop, right? I can apply the KVL in this loop. That will be 2.25 plus 0.7. IB current is flowing like this. So minus 100k into IB minus 0.7 is equals to 0. I started from here, 0 plus plus minus minus plus plus minus minus. That's it. Okay, so your IB current is coming out to be 2.25 by 100k. That means 22.5 micro ampere. This is your IB current. Okay, this is your IB current. Now coming to the VCE part. So you need to tell me the potential of this VCE. So IC current will be flowing in this manner from here. So this voltage drop will be IC into 1. And in the analog electronics, you will learn that IC is equals to beta IB. One more thing we have to consider here is that considering the BJT in, we call this bipolar junction transistor. Everything we will learn in analog electronics, considering the BJT in active region. Okay, we are considering the BJT in active region. Okay, so considering the BJT in active region, IC is equals to beta AB, that means 100 into 22.5 microampere. That means it will be 2.25 milliampere, right? So this is the value of IC. So you know the current here, the value of current here is 2.25 milliampere. So what will be the drop? 2.25 volt, right? The drop in this direction would be 2.25 milliampere into 1 kilo ohm. So 2.25 volt drop. So what will be the value of VCE? So the value of VCE will be, from here you will start, minus 2.25 plus 15. So that value came out to be 12.75 volt. So that is the value of VCE, right? This is the value of VCE, 12.75 volt. We started from here like this, minus 2.25 plus 15. So that is 12.75 volt, and here that is 22.5 volt, 22.5 microampere. So that's it about the assignment 2 actually, sorry, assignment 3, but that's a very short video of 21 minutes only. So I will solve next assignment in this video only. Okay, in this video only we will solve the next assignment, or we can make a separate video as well. There is no need to worry. So we will make a separate video only. So we will solve the assignment 4 in the next video. Okay, thank you.